Hello, my name is Vianne, and I am going to be doing a pencast for you on problem number 10 on homework assignment number 2. So the problem reads, standing waves on a 1.0 meter long string that is fixed at both ends are seen at successive frequencies of 36 Hz and 48 Hz. Part A asks, what are the fundamental frequency and the wave speed? And part B asks us to draw the standing wave pattern when the string oscillates at 48 Hz. So, reading this problem, you can notice that it says successive frequencies, which means that these frequencies can exist on the string at those two frequencies, but there are no frequencies in between. So it's one following the other. And if you know the meaning of fundamental frequency, you know that 48 and 36 are multiples of the fundamental frequencies. So if you want to skip all the work, you can find the fundamental frequency by just subtracting 48 Hz from 36 Hz to equal 12 Hz, and you know that that right there is your fundamental frequency. But usually on tests they will want you to show all your work, so I'll go ahead and show you the symbolic way of finding fundamental frequency. So if we were to assign them, first frequency, frequency A, to be 36 Hz, we know that this is going to be equal to whatever mode you have here times an initial frequency, and the following frequency, frequency 48 Hz, is going to equal the previous mode plus the next step mode, so you're going to add 1 times that same frequency that you used. So to symbolically relate these to each other, we're going to set a ratio up, that frequency over the first frequency. And if we were to plug these into here for the frequency A, frequency B, we would have mode plus 1 times the initial frequency over mode times that same initial frequency. And since we have the same variable in the numerator as in the denominator, we could cancel those out. And then relating these back to their value of 48 and 36, we know that we have 48 Hz over 36 Hz. And then if we want to simplify it, divide both by their common factor, and we have 4 over 3. This is all a ratio being used to help you find the fundamental frequency symbolically. So moving forward, we're just going to take this work and this work right here to make mode plus 1 over mode equals 4/3. So now we're in the place to be able to find what the mode equals. I would solve for this proportionally. You could all do it your own way. I'll do it step by step so you can see what I mean. So multiply both sides by m. Cancels out on that side, and then we're left with m plus 1 equals 4m over 3. And then we still want to find m, so we're going to try to get it by itself. Multiply both sides by 3. Then we have 3 times mode plus 1 equals 4 times the mode. We're going to go ahead and distribute that 3. And now we're going to try to get all m's on one side. And then we're left with mode equals 3. Now, we're going to plug it in, this m, our mode, equal to 3, to our first frequency up there. And this will get us I'll rewrite it just so you can see. MF1 equals 36. We're going to plug this 3 into that mode right there to have 3 times frequency equals 36. Let me write my units, because those are really important. You don't want to get marked down on the test. Divide both sides by 3. And then we are able to find that frequency, the fundamental frequency, equals 12 hertz, like we found up here when we subtracted, because they're going to be equal distance from each other if they're the fundamental frequency. But it's always best to show your work and get all the points possible you can on the midterm. Okay, so we just found our frequency. Now we're going to find our wave speed. And to do that, we're going to refer to the equations that we've learned so far up to this point in the quarter. If it helps, you could create an equation sheet to find what helps you best when you're solving problems. You don't have to, especially since you're not allowed to bring your own equation sheet to the test. But if it helps you, then highly suggest doing it. So if I look at the equation sheet, I find that the wave speed is satisfied by this equation. Fundamental frequency equals velocity over 2 times the length. And we're going to manipulate that to set 2L times frequency equal to velocity. So if we look at what we've gained so far, we have frequency and we have length right here. That's the length of the string that we're going to use. So writing out the equation, that's the frequency, equals velocity over 2L. To get it so that we have it equal to velocity, because that's what we were trying to find, I'm going to get velocity over here by itself equal to 2 times length times the frequency. Now we're going to plug in. So we got 2 times that length times the frequency we found. And it's 12 hertz, but hertz is also equal to s to the -1. And that will give us the units we need for velocity. So that equals 24 meters per second. And that completes part A for us. We have our frequency, we found our wave speed. Now we're going to draw the standing wave pattern when the string oscillates at 48 hertz. And we could do this with all the information we have gathered. So part B, we know that when the mode is equal to 1, our frequency is at 12 hertz. And then since standing waves are multiples of the fundamental frequency, we're just going to keep adding 12. So to give you an equation for that, fundamental frequency, mode times fundamental frequency, excuse me. So we have our F1 is equal to 1 mode equals 1 times frequency, which equals 12 hertz. Our F2 equals 2 times 12 hertz. So then we have 24 hertz. F3 equals 3 times 12 hertz, which equals 36 hertz. F4, sorry, I made a little mistake, so now we're at m equals 4 times 12 hertz, which equals 48 hertz. And now we're going to stop because part B is only asking us to draw the standing wave pattern when the string oscillates at 48 hertz. So what that will look like not a very good drawer, but we can pretend these are all equal. So this is at our m equals 4. Let me just backtrack to explain to you what has been drawn here. So, sorry. Imagine our string. It's 1.0 meters long, and we have all these waves. And if you remember from lecture, we have nodes in the middle. So frequency 0, nothing there, and then at our F1 equals 12 hertz, that's what mode 1 looks like. And then if we kept going, add a node, this is what F2 looks like, and then keep going, that's what F3 looks like, and then this is what our F4 looks like, so it's going to be up, down, up, down, up, which is what I drew here. So it's only showing this section right here if our mode was to equal 4. And then what I drew here was the reflection. And that's it for my video. If you need any further help, I highly suggest Khan Academy. That really helps me with creating this or referring back to the notes. And that's it. Good luck with your midterm.